Hi everyone, and thanks for watching my online lesson on finding the nth term of a quadratic sequence. So this is a higher tier only topic, and it is similar to finding the nth term of a linear sequence, but we've got an advanced step to start with. So make sure you're really good at finding the nth term of a linear sequence first before you attempt this. So a linear sequence always looks like something n plus or minus something, and that's what form a linear sequence takes. But a quadratic sequence has something at the beginning times n squared. So this is the form of a quadratic sequence. So when we find the nth term of a linear sequence, we start by finding the difference between the terms. And the difference between the terms is always the same thing. It's always going up in threes, or it's always going down in twos. With a quadratic sequence, this doesn't work. Here we have plus 3, plus 5, plus 7. So we have to find the second difference, which here is 2, in order to find out how many n squareds I have in my sequence. So we halve the second difference, and in this case, half of the second difference is 1, and that tells me that my sequence has a 1n squared in it. So I'm going to write out what 1n squared is, which is just n squared. I don't need to say 1n squared. So the n squared sequence is, well, that's just a square numbers. It's 1, 4, 9, 16. So my sequence here, my 3, 6, 11 and 18, has this in it plus a linear sequence. So it's this plus a linear sequence. So I need to work out the difference between my n squared sequence and my quadratic sequence. So my n squared sequence starts with a 1 and my quadratic sequence starts with a 3, so there's a plus 2 difference. My n squared sequence starts with a 4 and my quadratic sequence has a 6, so that's a difference of 2 again. 9 and 11, that's a difference of 2. And from 16 to 18, again, plus 2. So how do I write the nth term of this new sequence, this 2, 2, 2, 2? Well, it just has nth term of 2. So my quadratic sequence here is made up of the square numbers add 2. So the nth term is n squared plus 2. Here's another example. I'm going to do about 4 examples in total so you can see quite a range of examples. So starting off again by finding the second difference. We're always going to start with this same step. So my first difference doesn't work. If at this point you do get a constant term, then it's not a quadratic sequence, it's a linear sequence. And this is quadratic, so I need to find the second difference. And again, my second difference is 2, which means I'm dealing with a 1n squared. So 1n squared is my square numbers. Now the difference this time between my n squared sequence and my quadratic sequence, so from 1 to 3 is plus 2, from 4 to 8 is plus 4, from 9 to 15 is plus 6, and from 16 to 24 is plus 8. So this is my linear sequence, 2, 4, 6, 8. How do I find the nth term of that? Well, it's going up in 2's, so it's 2n. And the difference between the 2 times tables and this is 0. I could put plus 0, but I don't need to. So my quadratic sequence this time is made up of my square numbers plus 2, 4, 6, 8. So it's n squared plus 2n. That's how we make up this sequence, by adding these together. So my answer is n squared plus 2n. Here's a slightly harder example. Let's see what happens this time. So finding my difference, I've got 0, 2, 4, which again is 2 and 2. So half my second difference is 1. I'm still dealing with my 1n squared, which is 1, 4, 9, 16. Now the difference between this and my quadratic sequence from 1 to 8 is 7, from 4 to 8 is plus 4, from 9 to 10 is plus 1, and from 16 to 14 is minus 2. So this is the sequence I have. It is a linear sequence, so the nth term of this linear sequence is going down in threes, so it's minus 3n. And the difference between minus 3 and 7 is plus 10. So that's the nth term of the linear sequence I'm left with. So this time my quadratic sequence here is made up of the square numbers and this linear sequence, which is minus 3n plus 10. So my answer is n squared minus 3n plus 10. Okay then, final example. Let's see what happens this time. So my difference is 6, 10, 14. My second difference is actually 4. So half of 4 is 2, which means I'm dealing with the 2n squared sequence. So this time I've got to write 2n squared. So this is my square numbers doubled. So double of 1, double 4, double 9 and double 16. So this, my quadratic sequence, is made up of the 2n squared sequence and some linear sequence. So again, writing out the difference from my 2n squared to the quadratic sequence, from 2 to minus 3 is minus 5. From 8 to minus 3 is minus 5. From 18 to 13 is minus 5. And from 32 to 27 is minus 5. So this has nth term of just, it's minus 5 every time. So my quadratic is made up of the 2n squared sequence and minus 5. So the nth term of my quadratic is 2n squared minus 5. Here's two examples for you to try. The first one is a fairly standard question. It's like one of the examples that I've done. The second one is a bit of a challenge. Let's see if you can follow the steps to figure out what the nth term of that quadratic sequence would be. So pause the video and then unpause when you're ready to see the solutions. Here's the solutions. So the first one, you should find the second difference was 2, which means it's a 1n squared sequence. This is my n squared sequence here, and the difference between this and this is this sequence here. We have 1, minus 3, minus 5, and that has nth term of minus 2n plus 3, so it's n squared minus 2n plus 3. This one here, you have to be very careful when finding the second difference. It's actually going down 3, so it's minus 3, minus 5, minus 7. And the second difference is minus 2, minus 2. So half of minus 2 is minus 1. So it was actually the minus n squared sequence, which is here. And then again, finding the difference between these terms and this one. Every time it was 10, add 10 difference. So the answer was minus n squared plus 10. Or you could have written 10 minus n squared. But it's very difficult, very tricky to find the second difference correctly. Thank you for watching.